Selam Eylül. Erdem'i de biraz bekleyelim, sonra başlarız.
Merhaba hocam.
Selamlar.
Merhaba hocam.
So we were talking about character controller. I just want to add one little thing, and we will jump to another topic. So in this scene, obviously you won't remember all the different types of movements. Just know that those methods exist, and you can check the implementation details when you decide to use one of those methods. And for instance, you need to be able to decide when to use character controller's simple move method and when to use character controller's move method. I would say that simple move gives a cleaner look for the code, but character controller's move method needs some more code writing by your part, but at the end it gives you more control, and you can change how much it moves, how much it jumps, etc. So the problem is you need to take into account, you need to take time.delta time into account, and you need to write those kinds of code. But all in all, it gives you better control. So there are some more writings, some more lines of code, but I mean, it's up to your requirements to decide which one to use, which one works best for you, and you can check. I mean, if I were in your shoes and if I decided to use this simple move method, for instance, I would go to a, I don't know, search engine and write character controller simple move, and there are some tutorials that describes how to use this method in detail. So just know that I mean, the aim of this lecture is not I mean, making you memorize these lines of code. I don't also memorize, but I just know which kind of methods should be used in which game, etc. So think about those methods as such. And for instance, in this video, I haven't checked, but as you see, there are different videos or tutorials describing different methods and how you should use them. Yeah, so for instance, there are videos that take acceleration into account and stuff like that, but what I just showed you is some basic building blocks of some common movements. Obviously it won't cover every different game, but at least it will give you a direction, and it will show you where to look for when you find yourself lost. So yeah, this is all for character controller, and now let's uh, show you another powerful Unity feature, which we call NavMesh. So NavMesh comes from the word navigation mesh. The reason it's called that way is, by the way, I'm going to jump to a new scene. Um, the reason it's called this way is because this tool basically creates a mesh around the area that you can navigate to. Okay. So if I click play, I'm going to first show you the results. If I right click somewhere, sorry, if I left click somewhere, I turn towards this point and I go towards this point. So I'm going to click this point, and as you see, and if I click outside, it does not go outside. But if I click here, for instance, it goes. So imagine this kind of movement in a real-time strategy game, okay? So RTS is a pretty common way to utilize this tool, navigation mesh. By the way, if I click on top of the slope, uh, it also moves. And if I click downwards, it calculates the shortest path, and it does not jump. I mean, I could make it jump, um, but uh, it uh, currently looks, it currently thinks this part as unpassable, and this is why it didn't jump, but it instead moved around, you know. So yeah, for instance, if I'm going to click on this part. Let's see how this character goes to. So it does not uh, go on top of this, but it gets as close as possible. Uh, but if I click here, since there's a terrain that it can walk, uh, it utilizes this terrain and takes the path and walks toward that. But I mean, I cannot go there here. Even technically, it looks like I can jump towards this section. Uh, in code, it's not described as that, and this is why I cannot go on top of this part. But still, my character tries to get as close as possible, you know. So this is the end result. Let's see how we can make this possible. So for that, you need to open window AI navigation, and it opens a navigation section. You can of course move this around if you want, like this, for instance. But I like where it is currently, so I won't bother. So first of all, you will be noticed that in the scene window. By the way, I'm going to just drag this game section here and make my scene window bigger. As you see, there's a light blue coloring on top of my objects. This is my navigation mesh. So this is my walkable paths, you know, and I can uncheck this, and now it does not show my navigation mesh. When I check it, it shows again. Um, and it calculates walkable paths automatically with the click of a button. I'm going to show you how to do that in a second. But for now, important point is this gray box is not walkable currently, right? So this is why you need to, you can't walk on top of it. And also you need to see that this part is also grayed out. This is what this basically says that from here to here there's an unwalkable path, and because of that you need to go from this direction. Yeah. So to do that, to achieve that, you need to prepare this navigation mesh first. Okay. And if you have not prepared it, it looks like, actually I'm going to choose my environment, by the way, and I'm going to go inspector and disable my environment. As you see, my environment was everything except my character. So if I check it again, everything comes back. And you will notice that my environment is static. Okay. I'm not going to change it right now. I'm just going to show you something. So your environment needs to be static, but it doesn't, your environment has to be navigation static, okay? It doesn't have to be static, but it's at least has to be navigation static. So I'm going to make nothing static by clicking nothing. And I'm going to click yes, change children to change the settings of my other environment pieces in my hierarchy. So they will, if you click on if you click on those, nothing is static, everything is unchecked. But by the way, I was in the play mode, sorry. I should have quit the play mode. So now I'm going to uncheck this again, and I'm going to click yes, change children again, and now I'm going to click play, okay? And I believe nothing will happen when I left click. Oh, okay. For some reason it works. I guess it's because my navigation is already baked. I'm going to clear. So if I click scene, you see that my NavMesh is still here, even if my objects are not static. So let's try something, okay? So I'm going to go to scene, and I'm going to move this cube, sorry, this part, like here, okay? And I'm going to move this part here. You will see that I will walk on top of this since it's already baked. Okay. So there's an invisible walkable path currently. Since I have disabled static, for instance, in my code, since I have disabled static, these two could be pushed, etc., by other objects. For instance, some car would hit this wall and move it around. But the problem is navigation mesh is cooked here, and it will still behave as a walkable path. So if I click here, for instance, I mean, as you see, it treats my uh, cubes as ghosts, and if I click here, it treats my walkable path as real. It thinks there's something here, and it's because of that it kind of flies right now. It moved, it climbed to the navigation mesh, but there is not a navigation mesh. So I mean, I did some changes in my scene. I want to take those back. To do that, I'm going to change to another scene like this, and I will click don't save, so my changes won't be affected, won't affect the final result. And now I'm going to click my navigation scene back. Okay, so now let's try something else. Let's say that I really want to change my scene. Okay, to do that, first uh, I need to clear the navigation mesh by hitting clear. Okay, so now even if show navigation mesh is clicked, I'm not able to um, utilize the navigation mesh because it's not baked. To bake, I need to click bake. Okay, now there are some weird circles around it. I guess that's because currently I'm able to jump from here to here for some reason. Um, I believe it is due to uh, my my drop height. So if I make this, I don't know, 2.5, and if I clear and bake again, mm, sorry, I need to clear it and I need to reduce my drop height to 0.5, and if I bake again, you will see that it's not possible to jump from here anymore, and if I uh, change my uh, oops, for instance, I'm able to jump from here to here, as you see, but I'm not able to jump from here to here because it has more height, so it walks slowly. And what else can we change? So you can, for instance, change step height, the minimum amount of step that your characters can take, and you can also change the maximum slope. So this is just like the character controller, but now you are creating a walkable terrain due to what your character can do. So by the way, by character, we mean agents. So agent is the uh, moving units in your field, and you can change your moving units radius, height, maximum slope it can walk, maximum step it can take, maximum step height it can take, maximum height it can drop from, and maximum distance it can jump to. And if you are really interested, you can check what those mean, but for now we won't go into those details. But I just want to uh, show you one more thing. Um, and this is Um, I mean, this is the static thing that I was talking about. So currently, all the things in my environment are static. This is why there's a check. Now I'm going to uncheck this, okay, and change my children. So I want to try to bake now. For that, I'm going to clear and I'm going to bake again. So even if I click bake, there is not a walkable path. I'm going to go to my game view and click play to see how that is affecting. So even if I left click, there's an error, Set destination can only be called on an active agent that has been placed on a NavMesh. But there's no NavMesh that we have created, so we get the error. So to go back, um, we need to make our environments um, at least navigation static, okay? So to do that, I'm going to click my environments and um, oops, let's cancel that. And I'm going to check navigation static. And I'm going to change its children to navigation static as well. So if you click here, I mean, there's a minus indicating that some of those fields are checked and some of them are not checked. If none of those fields were checked, then this checkbox would be empty. If everything was checked, this checkbox would be checked, basically. But since some of those fields are checked, there's a minus sign indicating there are some fields that are checked. Okay, so navigation static is checked, and inside every, oops, I clicked it uh, without, I clicked it by mistake, so I'm going to hit navigation static again. I mean, for everyone of them, only, oops, I did the same thing again. For every one of them, only the navigation static should be checked. And sorry, uh, yeah, it's enough for them to be only navigation static. So now I'm going to go to my navigation window and I'm going to go to my scene window here. So I'm going to clear everything. I mean, there's nothing here, so it doesn't do anything. But now I'm going to click bake again, and it's created perfectly, right? So now I am able to walk again, just like this. So if you have an RTS game, if you are creating a game like Dota, for instance, or League of Legends, where your agents or units are moving to where you click, this is the way to go, I believe. And also, I'm going to save my scene. And also, you can change some uh, objects from here. So um, you can, you know, modify different terrains from here, and also you can um, define some different behaviors of terrains. Some of them will be walkable, some of them will not be walkable, some of them will be uh, jumpable, and some of them will be flyable. So if the agent is flying, it can go on top of those fields. But if your agent is not flying, then it can't go on top of these fields. So in Dota, for instance, there's a case like that. Um, I mean, it's not the Dota. So Dota 2 is not written with Unity, as far as I know. But if I were to write Dota with Unity, I would. define some different terrain behaviors here, and then I would go to my agents and define different agent types. So those are, I mean, the default type is humanoid, meaning that it can walk to some places and it can climb some mountains. But I would add another type, which is uh, flying units, and flying units would be able to uh, go almost everywhere in the game. Yeah, so this is all I wanted to say. Um, I'm going to actually uh, take some take a cup of water, and I will be here in a second. Okay, do you have any questions about navigation mesh, by the way? Um, it's um, it's pretty easy to learn and apply that in your games. So if your game requires this type of movements, you can uh, pretty quickly implement that. Uh, we created a tower defense game um, last semester, and we did not use navigation mesh. We implemented a popular algorithm called A star, which calculates the shortest distance from one place to another. But we could, I mean, it would be pretty easier to use navigation mesh now that I think of it. I thought that navigation mesh is pretty hard to do, but in contrast, it's quite easy. And I want to show you something, by the way. So if I go to inspector view, you uh, you should see that in my character there's a NavMesh agent component attached, and its type is the default type, which is humanoid, and um, I can mess with its speed, its turn speed, uh, its acceleration, and it does not stop until it arrives to the clicked point, but I can even change that. So it can leave a distance. Uh, so if I click to a shop, for instance, it does not go inside the shop, but it stays outside the shop and waits, for instance. Um, and you can change its radius, just like in the capsule collider, its height. Uh, I'm not sure what this is. Maybe, oh yeah, its obstacle avoidance is high quality, meaning that it checks for obstacles regularly, and it has a priority. So what does that do? Let's uh, hold our mouse on top of it, but it does not give any clue. Okay. So I don't know about priority, but I believe it's uh, the calculation priority. So when there are multiple agents in your scene, it gives way to some of them first, then it lets other agents to move. And yeah, this is all. And also we need, NavMesh agent and mesh renderer is Unity components, but we also have added a small script which lets us control this character. And this NavMesh character script is written by us, and let's see what it does. So it's pretty easy, pretty simple. Inside our update function, oh, by the way, inside our awake function, we find our NavMesh agent component, and we use get component method for that. And after that, inside our update function, if user clicked the zeroed mouse button, this means left click, by the way, then we do those things. So those things are, let's go one by one. First, we take mouse position and we cast this screen point to ray by this function. So a ray is a invisible line that goes from one point, that starts from one point and goes indefinitely to the direction. In Turkish, it's called ışın, you know. Bir noktası sabit, diğer noktası, diğer ucu sonsuza dek uzayan, sonsuz uzunlukta doğru parçası. It's in English ray, and you define a ray starting from starting from camera and goes towards mouse position. And if your ray hits something, then you get the object that your ray hit. So you do that by using an out parameter, you know. Did you use something like this before in your C# classes?
Actually, we used something like this in Godot last week. We are making a maze game, so
Okay.
our character shouldn't be turned around between the mazes.
Okay. So you have you know some stuff about out parameters, right? So basically, what this does is, this out. How can I say what is this? So this out keyword lets your function return more than one thing. Okay, it normally returns a boolean, but by the way, I believe this boolean means that your raycast hits something or not, but it does not return what it hits. Okay, and if you send another parameter, which is an out parameter, then it fills this object and it returns this object as well. So thanks to that keyword, you can get two information from just one method. So this is why there's an out keyword in C#. And you learn what you hit. So this hit information is of type raycast hit. And like I said, this function returns a boolean indicating that your raycast hits something or not. And this out parameter returns what it hits and some other information. So it has the point that it hits. It has the normal vector, distance, um, the collider that you hit, etc. So it gives you some information about the hit. And if you hit something, you need to calculate. Sorry, you need to decide where you hit. Okay, and you take hit info dot point, and you name it clicked world point. It will obviously be somewhere in the surface, right? And then you reach to your NavMesh agent, which you have initialized in the awake method. And then you set its destination to clicked world point. So if you click somewhere outside the terrain, it still tries to go there. If it hits something, if it tries to go there, but since navigation mesh is only around our terrain, it's not able to go anywhere else other than our terrain, and I'm going to play and left click to an empty space, and it even does not try to go near this point because it did not even hit something, If there was an object here, actually I'm going to create an empty object in my scene to show you something. Yeah, if I were to click, now it would try to reach this point. Obviously, it's not able to walk there, but it still tries its best to go near this object, Yeah, this is all I wanted to cover from the navigation mesh part. Do you have any other questions? And when I quit the play mode, obviously the created object is not gone now. So I said that ray goes indefinitely, but I believe it stops when it's something, when it hits something. So I believe it does not go indefinitely. But now, since we moved this out of the way, we can see, we can talk about animations. So animations are another cool way to move our objects in the scene. So I'm going to jump to my animation scene. First of all, I'm going to show you the effect, and then I will show you the ways to create an animation of it. So if I click play, now you see that there's an object that is moving without my control, So there's this cube is being animated by up down animator, and my character controller is controlling my character like this, and I'm going to try to jump on top of this cube if I am able to. Oops, it's pretty hard actually. So yeah, it has an effect like this. So as you see, it has trouble with the collision. You might actually say why is that the case. The thing is, our animating cube is probably kinematic. This is my assumption. Actually, it's not kinematic, but it doesn't even have a rigid body. Okay, this is why. So since it doesn't have a rigid body, I mean it tries to um, uh, teleport to the next location, and it actually pushes my capsule collider top when it realized that it is inside my capsule collider. So animations are cool ways to move an object um, without writing code. And if this object is just some visual stuff, it's not uh, affecting any other thing, such as my character controller. It's a good way to do that. But as you see, if you jump on top of an animation, you can get some weird results. There are some ways to, avoid that, overcome that. I'm going to actually try to add a rigid body and make this is kinematic so that it affects um, other uh, stuff, but it does not get affected. So it still has some problems. It's basically almost the same thing. So if I disable this is kinematic, now it gets affected by gravity. So it's pretty weird stuff. But all in all, like I said, animations are good, and you can check the ways to jump on top of animating boxes. But for now, let's get rid of this rigid body that we have added. It doesn't fix anything anyways. So let's see how we add an animation, okay? So um, to do that, I'm going to right click, create a folder, and I'm going to call this lecture animation. Okay. And inside this folder, I'm going to create an empty scene, which I will call lecture animation scene. And I'm going to go to this new scene. Do I want to save my changes? No, actually. So in this scene, I want to create create a 3D cube, and I want to add some animation on top of this cube. So to do that, I'm going to open my animation window. If you are not sure where to find your animation window, it should be here. So there's an animator and an animation. The difference is animator controls all animations. For now, we just need an animation. So let's say that if this tab is closed, I can basically reach to here, click animation, and an animation window pops up, and I can easily drag this here. and when after that animation, after opening this animation window, you need to check the cube that you want to move. So you need to click on the cube that you want to animate, and I will call this animating cube. And you will notice that in this section it says that to begin animating cube, create an animator and an animator clip. So if I change its name from here to animating cube 2, it will update its name because this is selected, it tracks what I am selected. So if I want to add some animation to the directional light, which is here, I need to click it, and now this says that to begin animating directional lights, create an animator and then animation clip. So this is a cool way to track where you are adding the animations. Now I just want to add animation to this cube, and this is why I'm going to go to animation window when it is selected, and I'm going to click create. So now I need to choose a folder which I would like to save my animation, and I have to write a name. I'm going to name this animation lecture cube animation, and it has, my animations always has a extension of .anim, basically ANIM, and I'm going to hit save. So after that, this lecture cube animation is created, and this is created. So this is a animator, by the way. Since animations are controlled by animators, it immediately creates an animator as well when you create an animation. An animator, as you see, there are different states. So as default, if your cube has an animation, right after it is initialized, the lecture cube animation gets played out, and normally it does not stop. So as default, it will be animated indefinitely, in a loop. And if you drag an arrow from here to here, it will do this one animation once, and then it will stop. So since there are different states in the animator section, we say that this animator is a state machine, or we say that this animator is a finite state machine, since it has a finite amount of states. State machines and finite state machines are common terms in software development as well. So just keep that term in mind. You might hear that often. And let's go back to our our scene window and our animation window that is here. Okay. So creating an animation is quite simple. I'm going to select my cube, and I'm going to click record. And now I'm going to change some properties of that object. So since I moved it a little bit, it created a point in this timeline. By the way, this is the timeline. And now we just have one point. So by and its Y position is 7. I changed it by hand, but it's okay. So now I need to have more than one point in the timeline to go between those points. And to do that, I'm going to record this and move this. Sorry, I'm going to go to this part in the timeline, and I'm going to click record, and I'm going to make its Y position 0, and I'm going to change its scale to a bigger scale. And to do that, I'm going to hit scale tool from here, and I'm going to make it a little bigger. Okay, just like this. And I want it to turn a little bit. So I'm going to hit my rotation, and I want to rotate it in this direction, just like this. Okay. It's around 45 degrees, but I'm going to actually do it like that. So now I have declared another point in the timeline, which has a different rotation, a different scale. Let's make those 2 to make it look simple, you know. And what else? So yeah, I'm changing some basic stuff. I can also, you know, change its color as well, but for now, let's not mess things up. And I'm going to quit the recording mode. So now, if I play my animation by going here and hitting play, as you see, it's quite nice. It's interpolating between those 2 points, and it completes the animation in less than 1 second. Okay, so to make those animation, oops, I clicked play. So to make those animation a little bit smaller, I can zoom out a little bit. I'm zooming out. I'm going to select these animations, and I'm going to, oops, I'm going to actually select this point. I'm going to hit Command X. Why can't I do this? And I'm going to, now okay, you don't hit Command X, but you can drag them like this. And by the way, a cool thing is you can copy some existing points. So I'm going to hit Control C, and if I go here to this point in time, I'm going to hit Control.V, and now if I play my animation, so it falls down slowly, and it goes up pretty quickly, you know. So this is the basic animation that you can use in your game. Like I said, there are ways to turn this into a walkable cube, but we won't delve into depths of that. You can check it if you need to. There are some nice tutorials about that. Okay, so this is, I mean, I played the animation from this animation window, but let's see what happens when I play the game itself, right? So it looks pretty nice. Um, you can do those kinds of animations if I mean, in pretty different games actually. If you want to have a boat in the sea, for instance, that your character is not going to interact with, you can create a moving boat that goes between three, four different points. Also, for instance, if you want uh, your character jump on top of a moving box, for instance, uh, in in platform games, this is a pretty common thing. You can move this box with an animation. So an animation is both for some nice looking visuals and also some set movements that are not affected by anything else uh, other than time. You can also have a crazy door that is opening and closing uh, from time to time. You can also have a hazard, and in some games there are some spiky walls that uh, from time to time closes and opens back. And if they touch your player, then your player is dead or your player loses some health points. You can do all those types of things with animations easily. So there are other ways to do that kind of movement, but if you use animations, as you see, it's pretty easy. You don't have to write code even. Yeah, so this is all. Any questions? Um, do I have any other thing to say? I'm thinking. Mm, yeah, so we have talked about um, teleporting the object with um, transform.translate, right? We see its uses. So its uses are if you want your object to teleport. For instance, if you have a um, board game uh, where your pawns or pieces can only be at certain spots, or if you have a game where you build some buildings at some certain spots, then this transform.translate could solve your issue. Um, but if you want a realistic movement, you need to add rigid body, and you need to control your objects by controlling your rigid body. You can do that by either controlling its speed. Uh, by speed, I mean velocity, or you can do that by adding some force to that object, or you can also teleport this rigid body as well, though it's not always recommended. Uh, by doing that, you can have an object that is uh, using the physics engine. You know, if you want your character be affected, sorry, if you want your character affect other objects um, with physics, but if you want your character not get affected by other objects, then you can make your rigid body is kinematic. So you can check is kinematic, and it won't be affected by other stuff other than your scripts. A character controller is an improved rigid body that lets you control your character um, with ease and with less amount of code. You can, I didn't say this, but you can also change how much gravity is applied to your character as well. So you can customize your character movements pretty easily. And this is useful for platform games, for instance, if your character can jump to differently, you know. And character controller can let you specify where your characters can traverse, where your characters can um, move to. And other than that, you need to know that there are two methods that are commonly used with character controllers. One of them is simple move methods. The other one is move methods. Move methods lets you go into the depths and control the movements uh, in details. And simple move uh, is just like in the name, lets you control your character pretty simply, and um it doesn't let you control the every details of the movements. Apart from that, you also have um, the navigation mesh, which is common in real-time strategy games or multiplayer online battle arenas such as Dota or League of Legends. This powerful tool enables you to uh, define a place for your agents to move to, and then your agents try their best to go to the selected destination point. And animations are used for either visual uh, enhancements for your game, or they can be used to uh, move objects in a predetermined format. So uh, if you have an animation, your objects will try to move uh, according to this animation until the animation is finished. In some cases, the animation plays in a limitless loop, and then it's uh, does not stop what it's doing. So yeah, this is how I summarize the different methods. Uh, Feel free to experiment, and we will have two more lectures together apart from this one. And uh, I'm going to actually ask you to show your codes in the last lecture. Even if you don't have any questions, we can talk about how to improve your codes, because there will be pretty different, pretty messy codes, I believe. And next lecture, in Thursday, I will talk about how to debug in Unity. So when a error pops up, you will be uh, able to determine this error with ease. Yeah, okay, this is all I wanted to say. Uh, so see you next week.
See you. Thank you.
See you. Thank you.
No problem. I will have an assigned for not today, but I will add some more days to it, so you will have time to upload. So check this assignment as well. See you.
Okay, see you.